Thank you. With that, we'd like to invite, I guess we'll take questions afterwards during our networking. So the next presentation is NVIDIA, Jason Tichy, Senior Solutions Architect. So thank you.
Hi, my name is Jason Tichy. I'm a Senior Solutions Architect with NVIDIA Federal. I am also an instructor with our Deep Learning Institute. So I can help anybody who has questions or wants to beat me up afterwards with the interactive talk. Today I just kind of want to talk to you about what's possible with GPUs and modern technology, give you a look into what's going to help your workload in the future and how it's being applied now. So to begin, my company's headline product, the Volta GPU board, Tesla. The Volta Cores, which you can find in the Azure cloud, the V100s, they're the latest technology in deep learning. There was a general from the Pentagon, I'm not going to use names because I don't know how open it is, but he was talking with our CEO at a computer vision conference, and he said he can really judge a company's seriousness and their AI and what they're about to propose by their workflow and how much of it was on a GPU. GPUs these days really do indicate that you are serious about deep learning because they accelerate the deep learning stack so much. With Volta, we have tensor cores, which do high-performance matrix math, floating point operations all the way down to integer operations to save on energy. And every framework spends time working with NVIDIA to make sure that it's accelerated on NVIDIA GPUs first. So CNTK, MXNet, TensorFlow, they're all embedding people at NVIDIA headquarters, making sure that those frameworks are accelerated as much as possible on top of NVIDIA technology. And so, like I said, you can find Volta in the Azure cloud, multi-GPU instances, and all sorts of fun. So why the rise of GPU computing? Why use it for artificial intelligence? CPUs typically, and they're beautiful and wonderful, they have to do so much. They have to play Angry Birds, they have to stream your Netflix, they have to do Microsoft Word. Intel and AMD, they have such a burden to have every language compiled down into them. GPUs are a little bit liberated from that in that we don't have to do so many things with our units. So a GPU, we call them Cuda Cores. They're algebra logic units. They are a core specifically dedicated for math, and we just do a ton of math. And so while a CPU, the best Intel you can get right now is a 20-core Xeon processor, we have well over 5,100 cores on an NVIDIA Volta board, and those can simultaneously just be ripping through your math. And so that's really at the heart of why we accelerate deep learning. Deep learning is a big pile of math, and so is your data analytics and everything. So if your workload is bogged down by math, even just moving the smallest part, just the math part, onto the GPU, you can get huge performance increases. And this is also huge for saving energy and saving money in terms of compute. Spinning up 480 CPU instances on the Azure cloud, you can do the same amount of numerical compute with just an 8 GPU single instance. So let's get a little bit into technology that's going to help you in the future. First, I want to talk about data analytics. GoAI is a GPU open analytics initiative, and their goal is to take the complexity of moving data around. So you have your data lake, and you've got to move data out of your data lake into your compute instance, and then you've got to do, you have your one tool that wants to use Hadoop, and then your other tool is very specific to a web database. But all the time you're moving data around. GoAI is an initiative to just take all of that data and leave it on the GPU and not move it around. So it's an industry agreement amongst the big players, Anaconda, Python, and a whole bunch of GPU accelerated database technologies. And their goal is to just leave the data in one place and leave it on the GPU and share it amongst all the programs so it can stay in one place. And the way that changes your workflow, these are the big, we're going to go through the keyword meat grinder here. So years ago it was Hadoop. That was the big thing. You wanted to parse the entire internet, you needed to spin up a Hadoop cluster. And everybody wanted to do Hadoop, and Hadoop was the big keyword. And then Spark came, and man, that was faster. Now we're taking the the computation to the data rather than the data to the computation. Okay, and that's really kind of standard right now, right? Is your Spark cluster for large data processing. So they've made a GPU version of Spark to speed it up just one little bit more. You have your HDFS read, and you go all the way to your machine learning training. With Go AI and leaving the data on the GPU, you no longer have the passing of data back and forth, and we're really working on like a 25 speed improvement, even over just the previous Spark generation. And the way you'd see this in your workflow, and so we'll knock on Amazon here for a minute because we're at the Microsoft event. Your Spark node cluster, I'm not even going to show you the top of this plot. It's tens of seconds to parse. So this is a data set that's used. It's 1 billion taxi rides in New York City. So the taxi companies collect all of their data, and can you parse 1 billion taxi rides and get the query out that you want? So that's tens of seconds to 85 seconds on a regular Spark node cluster. Okay, Amazon's going to make it faster. They're going to do Redshift, and okay, that's a little bit of improvement. MapD, if you saw on the previous slide, they're a part of the big Go AI initiative, and they make a GPU accelerated database, and they partner with Microsoft to run in Azure. And so with a MapD database, if you're using even just 4 P100s, you've taken it from almost 86-second query down to well under a second. And it gets even faster when you use, and I know I have my company's DGX1 instance. That is an 8 GPU instance in the Azure cloud. So you can cut that time in half. And one thing MapD likes to say is they had a customer in the intelligence community that had a query, and they came to them begging. It was an 18-hour query. Every time they wanted to look at something, they'd have to wait 18 hours for the database to return the result. And that was killing them. Can you imagine your data scientists, they come in the morning, set up a query, okay, they've got to, go home because they don't get the answer to the next day. So MapD took their existing data lake. They didn't have to change the data at all. They just had to put their MapD layer on top, which does SQL queries but uses the GPUs to shred through the information a lot faster than CPUs on a typical database would do. And that took their query from 18 hours down to 5 minutes. So you're talking about thousands of more engineering cycles and getting work done a lot more. So saving money, saving time, just by changing your database engine to a GPU accelerated one. And so now this is the topic for today was data analytics and AI in government. So I just wanted to hit on some high points of where you find data analytics and AI in the government. So one of the big emerging ones is cybersecurity. GPUs are using artificial intelligence and data analytics to go through cybersecurity at an unbelievable rate. They are able to track Bitcoin transactions and track dirty money all around the world by using high-speed GPUs to track them. Let's take a step down from the federal government. Pittsburgh and a couple other cities have approached NVIDIA, and they're wanting to put their cameras and create smart cities and do analytics on the cloud and at the stoplight itself to use artificial intelligence to help you with traffic. So hopefully artificial intelligence can make traffic a little bit better, but also do things like run warrants and other things to help the city manage its people and a lot of its people problems. Big innovations in healthcare. Object recognition from the top. I could talk all day about where artificial intelligence, I think every faction of the government has approached NVIDIA and probably a lot of your companies to try to figure out a way to use artificial intelligence and like he said before, not to replace people, but to help them. Everybody in government's looking for help. They want to do their job one step better. They want to take it to the edge, and artificial intelligence is there to help people. And so these are just even more, specific. NASA's using artificial intelligence to process ground data, to watch the Earth, to watch for global warming, or to find resources, or to better predict the track of a hurricane. I mean, we all hate how they predict the weather now, so artificial intelligence can totally help us there. Looking at overhead data and picking out threats or tracking people. There's just a ton of usage for artificial intelligence everywhere. So what's possible with GPUs today, really, especially with Volta technology, is it used to take you a long time to collect your data, and then you had your data scientists analyze it, but now you have the compute power in a GPU to bring that to real time. You can watch your video streams real time. You can, do analysis on Twitter feeds real time. You don't have to wait to collect it all. You can just take it all in and apply an artificial intelligence to it and infer an answer. With the power of this, I mean, if you've watched artificial intelligence grow over the last 5 to 7 years, it used to be AlexNet in 2012, which is a maybe 2-digit layer, 10, 12 layers. Now there's ResNet 350, which has almost 99% accuracy when looking at faces. I mean, Facebook knows your friends better than you know your friends. They can, it's scary. We spent years tagging our friends and helping Facebook build that database, but now Facebook now tells you when you're in a photo. And it's really accurate too, right? Like when's it been wrong? And so that's kind of my talk today, and we can open it up for questions. I know I was probably faster than everybody, but.
Did you say beating you up after the session was fair game?
Yeah, beating me up is fair game. Anybody have complaints or they want to talk about AI?
So I envision one of your NVIDIA GPUs in Azure.
Okay.
And started to run an algorithm, and it's surprising reasons the speed of the algorithm was not faster than the GPU CPU ones. And that was used by turns out.
I was about to apologize. I'm glad you.
Recognize that it was a GPU, right?
Oh, okay.
So I thought it's just was to do that, go out and get the NVIDIA driver and do it at the same time. Not simply say, oh, wait, I have the GPU and I can run much faster.
Okay.
So something to be back that when I get a GPU, I should have that driver. That was the beating up.
And NVIDIA is working to kind of try to bring this in. There's lots of clouds, including Azure. NVIDIA now has our cloud repository, which contains Docker containers, which when you run it on a GPU instance running Docker, you can connect it to NGC, NVIDIA GPU Cloud, and you can pull that Docker container and all the frameworks and everything are ready to go. So with clouds, it's tough to manage every image, right? Because there's a community image, and they forgot to install the driver for you when you selected that image. So, trying to solve it slowly. Yeah.
Is ASIC development on the product roadmap, and if so, what kind of additional performance improvement do you set?
Is ASIC on NVIDIA's roadmap? ASICs are very, as the acronym is, application specific. you can see us react to Google, their TPUs, and that our Voltas now have tensor cores. But it's very, very tough. So you find the world of ASICs, and an ASIC is faster than a GPU at some things. For instance, there's an ASIC in your phone, so you can say OK Google or OK Cortana, but it's only going to ever respond to that one command. And so that is good, that is powerful, but the reason to use a GPU is that with a GPU, you could at the edge change that command and change it, whereas an ASIC is cut exactly how it is. So we do include things like the TPU that does the matrix multiplication blazingly fast, especially if you hit some factor of a 4x4 matrix, say like 64 by 64. And it looks like an error when you do it. If you do just matrix multiplication, you look at the performance graph, you want it to be this nice smooth performance graph as the matrix gets bigger, but when you hit that sweet spot on the tensor cores, suddenly your performance jumps and then comes back down and then jumps because you hit those sweet spots that the TPU is really good at. But we do, as ASICs become more prevalent, like I said, like the TPU, we do try to include that hardware in our future builds, but we also try to make a product as general for the world as possible. So ASICs hit 5% of the world. We want the other 95%.
Thanks for your presentation. I think you can work on this positive way, but my question will be on a negative way. I know a lot of people, whether in the private sector or in the public sector, NVIDIA employee or their coworkers, before some people file or people government file, maybe administrative complaint or judicial complaint. So by this machine language, you will be able to go there to fix it before, and she was doing it wrong.
Yeah, so I mean, exactly. With the high speeds, you can kind of see what happened. You can do forensics, especially if somebody's trying to penetrate a network, whereas before it was an if-then block of rules as to what traffic got in. Now artificial intelligence can tell you, this is my normal state. Okay, well last Tuesday this happened that was nowhere near normal, and it can flag your IT staff to say, hey, you're having some sort of non-normal activity on your networks, you should check it out. And it's a lot more accurate and actually helps your IT staff do more important things because it can monitor the network for abnormal things rather than just set rules.
Wonderful. Are you aware of any agency doing such a good work?
Am I aware of what?
Any government agency doing such a good work?
They're all interested in it. I mean, NVIDIA is a global company. England has approached us, the federal government, a lot of the actual just agencies, NASA, everybody wants to use artificial intelligence to monitor the networks and ensure their infrastructure.
Yep. Last question, I think we're exactly at 8. Microsoft is also on Azure Gov putting out FPGAs, which in some cases, just for the right sweet spot, outperform GPUs, right? Is something you want to talk about the difference or between FPGAs and GPUs?
FPGA is one step away from an ASIC, right? So FPGA is programmable. You have to program in VHDL, which is, if anybody's ever done that, it's incredibly fun and I love it. So FPGAs are incredibly great at that speed, for instance, and GPUs are approaching the speed of an FPGA, but we're still not quite there because of the time it takes to launch a CUDA kernel versus an FPGA is just already ready to go. So for instance, radar processing, FPGAs are famous for just pulling the data stream off of the radar and processing it and then putting it into Ethernets for computers to understand. Now they're starting to put the GPU right behind the FPGA so that the FPGA pipes right into the GPU to do the analysis right there rather than trying to store it and then post-process the radar data. So the GPU is approaching the FPGA speed, but the FPGA is still currently faster and it has its place in the world.
Thank you, Jason.
Yeah.